Good morning. Today we're going to be talking about what happens when we need to rearrange items and order doesn't matter. When you rearrange something and the order doesn't matter, we call that a combination. A permutation, order matters greatly. That was yesterday's work. And with the permutation, we always would say words like pick and selected. But when you're talking about a combination, you're going to be talking about choosing or selecting. And in those instances, order doesn't matter. It just matters that you were selected. So let's start with permutation and build into a combination because that's what's going on here. So this very first thing says you have these four letters, M, A, T, and H. And we want to determine three-letter codes. Now, again, a code order matters because, you don't put the code in right, people don't know what you're talking about. So there's 4, and then 3. So in a code, order matters, and you can write this out or type it into your calculator. I mean, the more you use your calculator, the better you'll be with always getting these right on a test. And you get 24. Now, part B says, consider now that you're only allowed to use these 3 letters. That's it. How many ways can these be arranged? And again, keyword arranged, order matters. This would end up being 3P3, which is 3 factorial. We talked about the factorial. Now, the factorial means you are multiplying by everything that comes after that on the number line, before it rather. I'm sorry, I said that wrong before. So 3, and before 3 on the number line is 2, and then on the number line is 1, and then this matrix. So if you only have 3 letters to rearrange, excuse me, and you want to rearrange them, there's 6 ways you could do that. Now, because that number is so small, we can actually write this out. So if we write this out, we have, so annoying. Let's start again. All right. So we could have M, A, and T. We can have M, T, and A. We can we can have A, M, T. We can have A, T, and M. We can have T, M, A. Or lastly, we can have T, A, M. So there we go. There's our 6 different ways we can do this. So they say, using your answer to parts A and B, calculate the number of 3-letter subsets. Now, the minute they say a 3-letter subset over here, they're saying order now isn't going to matter. So the minute they do this, they're telling me order does not matter. See, they were using the word code here. And here, order's mattering. They use the word arrangement, order matters. Now they're just saying, hey, I want a subset. I want to dump these things into a pile. How many ways can I, dump them in the pile? And that just basically means the order isn't going to matter. You're going to be using the same 4 letters. And so this then looks like this. I'm going to actually use the math keys for this. So here, I am going to have, I think I'm in the right spot. I can't tell with this right now. 4, and then P, and then 3. Let me see if that actually worked. The 4 did it. All right, let's go back and see if we could fix this. Actually, once this doesn't work, you can't fix it. I forgot about that. So let me just get rid of this and start it again. All right. So I need, okay, 4. And then I need the P. And then I need the 3. So on my calculator, I have 4P3, and I know that that's 24. And then and then below that, they're now saying if I then take part B and I put it underneath 3 factorial, which happens to be 6. Then together, I am going to equal 4. So there, this way you can read it. I know it takes a little bit longer when I type, but I just think that if you need to go back on the video, you'll be able to read what it says better. So what this is saying now is that there are 4 ways letters can be shuffled when order doesn't matter. So when order does not matter, there are 4 ways to shuffle these letters. And that's pretty important. That's pretty significant. And again, we call this a combination. So a combination, order doesn't matter. They say this right up here. Permutations, order matters. So when you have a permutation, ordering the elements in the subset absolutely matters. Whereas a combination, it doesn't. It doesn't matter with the combination. Now, in a combination, you'll see keywords which would be choose, would be the biggest one you'll see. You'll see the word select, and you'll see the word group for the most part. Sometimes the word, actually not sometimes, many times, the word committee. I think I spelled committee wrong. I might have. Let me see. Nope, I didn't. Okay, good. So you want to look for these words. So Janine would like to select. Now here's the word select. So again, this is one of our important words. She wants to select 3 DVDs, and she has 22 to choose from. So you can tell this is an old Ditto handout, rather, because you guys don't use the word DVD anymore. Everything's on your phones. All right, so we would write this then as 3 and C. I'm sorry, I can't fix that. So one more time, we would write this as 22. She has 22 DVDs. She's going to choose 3 of them. And so if we were going to write out what this is using the formula from above, we can do that. If I have 22C3, the formula from above says that this clearly is going to come from 22P3 over 3 factorial. And if we write out exactly what that gives us, 22 pick 3 numbers means you're starting with 22. You're going to multiply that by 21, and then you're going to multiply that by 20. And this is going to all be over the 3 factorial, which is 3 times 2 times 1. And I know anything times 1 is itself, so maybe you don't want to write it, but I mean, it's just a good habit. And then this, if you worked it out on your calculator longhand, you would have 9,420 over 6, which then would equal 1,540. So you could write it out and use the formula. Now, I know most of you are not going to want to do that, so good news, let's go to the calculator. And even on the old scientific calculators, you could probably find the probability someplace on it, because all scientific calculators have the permutation and the combination. But on this guy, we hit the word math. Again, we go over the probability, and now there's number 3, the C key. So for my old calculator, and even the new ones, I need to start with 22, then I hit math, and go to probability number 3 menu, and then hit the 3 that I want, 22, pick 3, or choose 3 rather, and there I am immediately at 1,540. So from this point forward, I'm probably not going to write all this stuff out because it takes so long to type. I'm going to use the calculator, and I would encourage you to use the calculator as well, because I'm not really going to ask you to use the formula for this. I mean, this is a calculator. I'm just going to ask you to use the calculator. The one thing I am going to highlight on this is the use of the keywords, so we know the difference between a permutation and a combination. So here, Mr. Wheeler's math team must choose. So there's my keyword. It has 12 members, and we want 4 of them. So the minute they said the word choose, we have 12, and we're going to choose 4. So go ahead, put that in your calculator, and then look to see, do you get what I got, which is 495 ways he can choose 4-member groups. Order doesn't matter. Once you're in a group, you guys get together, you start working. Nobody cares the order you were chosen. So use your calculator and 10C4, do that, then check your work. Try the next one. Now check your work. Now on this next one, first type in 4C2, do that. You should have gotten 6. And then type in 6C5, and you also get 6. So now multiply these together, we have 36. Type in 6, choose 3, 6C3. Did you get 20? Now you have to type in 10C3. Did you get 120? And this would reduce to 1/6. Now, this part here is really important because here now we have a bag with 12 marbles. So picture this little bag, it's got 12 marbles in it. And these 12 marbles have 7 red and 5 blue. So you reach into the bag and you pull out 4 marbles. So if you wanted to do this and we don't care about the color, we would say overall you had 12 marbles and you chose, you stuck your hand in and you grabbed 4 without looking. That is purely random. That would give you 495 ways this could have happened. There's 495 different ways you could have pulled out 4 marbles. But now, if we look at part B, they want to now put some conditions on you. They want you to have 2 red marbles. Well, the minute they put a condition, you have to say, well, there were 7 red marbles. So what this means is from 7 red marbles, I want to choose 2 of them. And if you recall, the word and means multiply, still means multiply, not going to change. Blue, I want 2 blue marbles. So now the condition on my 5 blue marbles is I want to choose 2 of them. So here we get 7 choose 2. If you use your calculator, that's 21. And 5 choose 2, using your calculator, that's 10. There are now only 210 ways we can do this. Part C, how many of these will contain all red marbles? So now it's like we really only want the red. Well, there were 7 red, and we chose 4. Well, 7C4 is 35. And how many of these sets will contain all red, which we just saw was 35. That was our 7C4. And if you recall, the word or is add. So and in probability is multiply, or is add. All blue, well, there were 5 blue marbles. So now from the 5, I want to choose 2 blue, and that gives me 10. So this now gives me 45 ways I can choose all the same color. So It's so important. The wording matters. You want to look for the keywords, but this whole packet is all about combinations. So as you're doing it, know you're using the combinations, but look for those keywords and give it your best shot. I will have the answers posted tomorrow morning like I always do, but send me questions and I will do my best to help you out. All right. Have a good day.